All of you, good afternoon. Am I audible to all of you online? Am I audible? Can you confirm my voice? Yes? Okay. I'm streaming fine in that case, right? Good afternoon, Isha, Prasad, Ubair, Darshan, Anugya. Good afternoon. So yesterday I was flooded with lot of queries. Let me clarify some of them. Okay, most of you want to know more about the ozone thing. ठीक है, देखते हैं. Point is, my question to all of you is, how do you know something is not in syllabus? Because you end up asking more on that. Okay, जो syllabus में है वो नहीं पूछते हो आप लोग. Okay, you have some way of knowing कि ये है नहीं, इसी में पूछो. Right? Something gives you confidence there. Hi Abhi, good morning. Where can you ask? I think I shared my phone number to all of you. Whatever queries you have, if you are unable to manage, then please get on the WhatsApp and you can ask me. But try not to call me is my request, because unless I know your number, I don't pick up your phone otherwise. Okay? And any time is fine. Okay, let's quickly get on. So we have covered 2-3 things yesterday. One is, okay, what is the atmospheric composition? Okay, composition includes, I said, dust particles, aerosols, we have ice, crystals, we have water vapor, water droplets, and we have gases. We also add pollutants, but pollutants, remember, they actually are not part of the atmosphere naturally. Hi Preetha, good morning, good afternoon. Okay, hello, yes. So of this, gases jo hain, this make up the bulk, and these also play some roles. These are very important for precipitation. The word precipitation is the word that captures water falling in all the forms. Precipitation is snowfall, precipitation is rainfall, precipitation includes the hailstones. Okay, सब कुछ मिला के we call that as precipitation. Not just water droplets, even ice and snow falling is also precipitation. So ये तीन का बहुत important role है in precipitation. I explain this how, because we have some topics on artificial rain and cloud seeding and all of that. Okay. Now this is a very, very variable component. This is variable. So in most of the atmospheric composition data, okay, these are considered as seasonal changes, diurnal variations. Okay, but gases is what we focus on. So we have the big ones, nitrogen and oxygen, and then we have even argon is 0.93 approximately. So that's also discernible. The rest is very less. We have carbon dioxide 0.03. We have helium, we have ozone, we have krypton, a lot of other gases that make up the atmosphere. And one important discussion we had yesterday was while these are important for other aspects of life and living, but atmospheric processes are because of these. Okay, so I made a statement. We said bulk of the atmosphere does not play an important role in climate processes. Okay, 99.9%. Nitrogen is 78%, oxygen 21%, argon 0.93%. Add up kar lo. It is 99.93% of atmosphere does not play an important role in atmospheric processes. Okay, why? Because these are not greenhouse gases. So one important appreciation in this will be that whatever climate process we have, you talk about winds, you talk about cyclones, clouds formation or fogs formation or rainfall, you talk about snowfall, you talk about hailstones, जितने भी आप सोच सकते हो, hailstones, some things like, very powerful one, cloud bursts, all of these are atmospheric phenomena and elements. They are the consequence of atmosphere trying to balance heat energy. Some places are more warm, some places are cooler. Some places have more energy, others have less energy. Some places are receiving energy, some places are giving off energy. ये जो energy का variations हैं, that is what results in all these climatic processes. That is why, the important atmospheric components, carbon dioxide, water vapor, methane is also natural part of atmosphere, even dust particles, they have some role to play. These are the ones that impact these conditions. और इसमें हमने pollutants add कर दिया है, which are not natural, like carbon monoxide हमने add किया. We've added what's called as fluorocarbons हो गया. We've added chlorofluorocarbons हो गया. So all of these are pollutants. They're not natural, and they also play a very important role in climate processes. So that's one important insight into atmosphere's composition and what they do. Hi Shweta, good afternoon. Yes. Oh, cricket shots. I have always wondered what your name is otherwise. I see you on the essay sessions also. Good for you. Nice. But happy to have you. Okay. Yeah, tell me. So any questions on this, anybody? So greenhouse substance क्या है? A substance which is capable of trapping solar energy directly or indirectly. Directly as ozone absorbs करता है, and carbon dioxide, water vapor can absorb indirectly also the energy that earth gives out. So those are called as greenhouse substances. Any questions on this, anybody? Any doubts on this? Are you all attentive? Someone tells me कि अभी आप गियर में पड़े नहीं हो. Online हो गया, good afternoon हो गया, ठीक है. Good for me, good for you, good for everybody. Now पढ़ाई करते हैं. कितना विश करोगे मुझे? इतने इज्जत के लायक मैं हूँ भी नहीं शायद. So it's okay. That means thermodynamics. ये कहाँ गया बेटा? Ubair, where have you gone? This is, it's linked, but why go that route? मैं अपने औकात में रहूंगा, so I will not enter thermodynamics. It's okay, don't have to get sorry there. I can move on now? Then we discuss something on what is the layering, what is the structure of atmosphere. So we talked about the concept of a homosphere, and we talked about a heterosphere. Okay, homosphere is up to 80 kilometers. Atmosphere is well mixed. Above this, there is some layering: hydrogen, oxygen, helium, nitrogen, oxygen, helium, hydrogen. Okay, so I remember this sequence: nitrogen in molecular form, oxygen in ionic form, helium is a molecule, this also in ionic form. So this is the layer of ions and gases above 80 kilometers. Okay, ionosphere is what we have talked about. Yes, okay. So that's one. Then we talked about the stratification of atmosphere in terms of its density. So atmosphere is a mixture, a very good mixture. A very important point we stressed on is that atmosphere is a mixture. It is well mixed, and the gases, they do not segregate, okay, on the basis of molecular or atomic weight. So the heterosphere is not the main atmosphere. In the heterosphere, we do have segregations. Okay, in general, the atmosphere mein, the gases do not separate out in terms of its molecular weights. The gases do not separate out in terms of their ionic weight or atomic weight. हाँ, तो अबे कह तो रहा हूँ एक्सेप्शन है. Okay, जैसे कि मैं जिंदा हूँ, okay, until I have 2 pegs, okay, then I'm dead. I am alive, except for, okay, when I'm sleeping, I sleep like a log. तो एक्सेप्शन वैसे ही कुछ सोचो. Okay, so for much of atmosphere, और यहाँ पर आपने देखा भी है कि यहाँ पर एटमॉस्फेयर कुछ खास बचता भी है नहीं. By the time I come to 80 kilometers, much of atmosphere is gone. It's less than 1% of atmosphere at those heights. So for the bulk of atmosphere, the atmosphere is very well mixed. Okay, but its mixing में we do have density layering, as in the lower layers, the molecules are more packed, more density. As they go up, the atmosphere becomes more rarefied. Okay, and why this happens? Because I said atmosphere has weight and atmosphere is compressible. The atmosphere का अपना weight है. This weight can compress the gases, okay, below. As they rise up, there is less amount of air. So this can compress less. So if you look at the atmosphere layers, the lower layers are very closely packed. When I go up, the gap increases. When I go up, the gap increases. The gap increases more. Can you all imagine this now? So in the lower layers, there is more densification. In the upper layer, there is rarefication. Okay, and we had a graphical representation like this. At the sea level, okay, the pressure is 1 atmosphere. At 5 to 6 kilometers, it becomes half atmosphere. Around 10, 12, 13, okay, it is just quarter of the atmosphere, 0.25 left. By the time I hit 30, 40, okay, it's already 90% gone, just 0.1 atmosphere and so on. Okay, so it's a very rapid decline. That's why I'm saying by the time you are hitting, okay, stratosphere, क्या ही gas रह जाता है? I mean, I was seeing some graphs on the net. It's almost like this line is coinciding with almost zero pressure. ठीक है? Yes, you are right. That is the principle of constant proportion, but you do have density stratification. Atmosphere contains salt crystals, and why does it rainfall doesn't contain salt concentration? बेटा होता है, you can't taste it, right? It's like, रिवर वाटर को हम स्वीट बोलते हैं, ओके, बट इट्स नॉट दैट कि रिवर वाटर डिस्टिल्ड वाटर थोड़ी होता है, इट ऑल्सो हैज सॉल्ट्स, ओके, सो इट्स हाईली डाइल्यूटेड, okay, you can't feel it, but no natural water is distilled water. You'll have some minerals, okay. When I say sweet water, so yes, rainfall also, in fact rainfall में तो pollutants भी हो सकता है. I'm sure you have seen one initial rain Delhi में सारा कपड़े वपड़े सब काले हो जाएंगे, okay. अब आप टेस्ट नहीं कर पा रहे हो अलग बात है, but believe me, the dust particles also has taste, okay. You need to have a sensitive, आपके लंग्स को पता नहीं चल रहा, आपको लग रहा है, okay. So yeah, yes, the atmospheric pressure is related to atmospheric density. The percentage is of dry air. So whatever percentage you talk about, 78% nitrogen, 21%, I am removing, okay, water vapor from it. Then I give the percentage. इसमें, okay, that's how it's calculated. Yes, water also has acids. Fine, take it. Let's move on. So that's the layering, and the third layering is on the basis of temperature patterns. How does atmosphere cool? How does atmosphere warm? Is it warming from above? It's warming from below. So I think I understood that concept already. So we have the 4 layers, okay. The troposphere, the mesosphere, sorry, yeah, I was checking your alertness. So the stratosphere, the mesosphere, and we have the thermosphere. On the basis of temperature, so one of you asked me, sir, thermosphere को ionosphere बोल सकते हैं क्या? You can, but thermosphere tells the temperature patterns. When I use the word ionosphere, then I am talking about the composition. So on the basis of temperature, हम यही 4 नाम use करेंगे. Troposphere, where temperature falls with height, okay. Stratosphere, where temperature rises with height. Thermosphere, again it rises with height, और ये transition zone है, heated from below. So this will be warmer and this becomes cooler, falls with height. Okay, the question, why does mesosphere temperature fall with height? Because mesosphere का heating जो है, it is from the stratosphere onwards. Whatever heat is trapped here, this is warm, and this makes this layer warm. This layer will make this layer a bit less warm. This will make this layer a bit less warm. There is effective cooling with height. ठीक है? And so troposphere में the heating is from below. Stratosphere, the heating is from above. This also heating from below, and this is heating from above. So when I say from above, I mean it is the insolation heating. When I say from below, it is the loss of heat from the Earth's surface that warms. It is not the insolation directly warming. Okay, energy comes in, the surface absorbs, the surface gives off heat again. Okay, it loses heat because of radiation or conduction or convection. So when the energy is losing from the surface, that starts warming. Okay, so that's why heated from below, heated from below, heated from top. Okay, and यहाँ पर important discussion was of ozone layer. So one of you asked me, why is ozone in this layer? Okay, it's a kind of, you can say, an insolation and dissociation balance. Okay, यहाँ तक there is not much atmosphere to trap insolation. Okay, you have got more gases here. ऐसा नहीं है कि यहाँ ions नहीं है. You also have ions here. Okay. But ions are less because the molecules are less. Okay. So here you have got more molecules. You have got more molecules, and these molecules can break up the oxygen ion, and we have ozone. यहाँ तक आते आते ultraviolet is over. Had ultraviolet been more here, तो यहाँ पर भी होता आपका ओजोन, और यहाँ पर तो molecules ही नहीं है ज़्यादा. So it's a kind of a balance. Okay, balance between insulation and the amount of atmosphere which can break up the molecules, which can get ionized or dissociated. Take all of you here. Okay, the patterns of heating and cooling, all of you done here? Yes.
Just like also near stratopause. Will it allow to heat pass from stratosphere to
पढ़ाते हैं वो नेक्स्ट स्टेप. आगे बढ़ गए हो आप, आज बताते हैं वो क्या है. Okay, we'll come back on that. Anybody else on this? Anybody else on this? Yes. इतना जानते हो, रीजन भी जानते होगे. ठीक है, आप मुझे टेस्ट कर रहे हो. ओके, कोई बात नहीं, बताते हैं, वो भी बताते हैं. ठीक है, there's some nuances. I'll come back on this. But tell me, you understand this pattern or not? All fine here? I told you 3-4 things about troposphere. One is it cools with height. Troposphere has lapse rate. We call this as normal lapse rate. NLR बोलते हैं. 6.4 centigrade per kilometer. Troposphere is also the weather layer. The weather gets trapped here, and I give reasons of why the weather is trapped here. This is where you have got absorption. This is where you have variations in insulation. The tropopause can trap it. The lapse rate is because of which we have atmospheric circulations. Some details here. Then I was discussing details of the stratosphere. So I entered into the concept of ozone. Ozone, मैंने आपको 4 चीज बताया. One is ozone is continuously forming and getting destroyed. It's something called as Chapman cycle. It's a process that happens in the presence of some catalyst. Okay, so Chapman cycle, that's one fact. Second fact is ozone is formed because of insolation. So wherever we've got more insolation, we have got more ultraviolet, वहां पर ज्यादा ozone बन रहा होगा. And more insolation is where? In the tropical areas. So tropics is where the ozone is forming more. Okay. But then we said, if I look at the ozone distribution, okay, ozone is more at the poles. Okay. Ozone is more near Antarctica and Arctic regions. That's because there's some mechanism by which ozone gets transferred from tropics towards the poles. We call that as the stratospheric winds. Okay. So, 2 reasons why the ozone concentration is more at the poles and less at tropics. One is tropics mein ozone is created, and tropics is where ozone also gets destroyed. Destruction because of, I said, NOx components, we have got hydroxyl from water components. So reactions may, ozone also gets destroyed. And for this, you need warm conditions. Warm conditions may the destruction of ozone is also more. In the Antarctic regions, Arctic regions, colder. So cold conditions may you'll have less amount of destruction. One. Number 2, I said the stratospheric winds, they accumulate ozone towards the poles. There's one discussion we had about the ozone. And ozone hole, मैंने बताया, actually hole ऐसा है नहीं. It's a phenomena by which the ozone concentration becomes less. The concentration is measured in terms of, I'd say, Dobson units. The Dobson unit average Earth का है 300. Average for Arctic regions is more than 300, can hit 500 also. Tropical areas, Dobson unit is around 200, 250 types. So in the Antarctic regions, when the Dobson unit falls to 100 and below, then we refer to that phenomena as a ozone hole. Otherwise, ozone hole is not a hole. It's only a condition where the ozone concentration becomes less. Okay? उसका बताया reason मैंने. The tropical areas, the mid latitudes, they produce more of artificial ozone depletion substances. Okay, so the tropics and the mid latitudes, there is natural rate of ozone depletion. This is part of the Chapman cycle. Ozone बनता भी है, ozone destroy भी होता है. It's like life and death. People are born, people die. It's natural. But then we said industrial process, certain emissions, certain aerosols, these can destroy ozone, okay, because of human activities. Okay, and these substances are called as ozone depletion substances. Example of which is chlorofluorocarbons, even carbon tetrachloride, hydrochlorofluorocarbons. Okay, they can destroy ozone. The stratospheric winds, they take this towards the polar regions. The stratospheric winds. So ये produce कहाँ हो रहा है? ये produce हो रहा है tropics where people live, as simple as that. If you have heard about a gas called as freon gas, अब ये phased out है. Freon gas was a very important gas in refrigeration. Okay, AC में use होता था. And this would release lot of these chlorofluorocarbons. Okay. So you are producing where people live, urbanization mein. Lot of spray paints, fire extinguishers, they would have these substances. You're producing here, the winds carry these towards the poles, and at the poles, okay, they will destroy the ozone layers. ठीक है? I don't know, निर्वासन पहले इस पे फोकस करो. All done, all of you? Okay. So we have tried to reduce this. We have what's called as Montreal Protocol. The Montreal Protocol was for banning ODS. And we successfully did it. Okay, it was one of the oldest convention bolo, conference bolo, okay, a treaty, and a very successful one. All countries have done this. Okay, it's a model in case of how countries collaborate. Okay, so one if you asked me what is Kigali, so Montreal Protocol was followed up by लंदन कन्वेंशन, कोपेनहेगन कन्वेंशन, और सबसे रिसेंट में हुआ था किगाली कॉन्फ्रेंस. Okay, so ODS were chlorofluorocarbons, ODS were carbon tetrachlorides and others. So they replaced this with substances which were not ozone depletion. So not ozone depletion was hydrochlorofluoro, okay, carbons, or rather I say hydrofluorocarbons, not HFCs. HFCs, hydrofluorocarbons, these are not ozone depleting. Don't confuse between chlorofluorocarbon and hydrofluorocarbons. But what happened was, this is a greenhouse substances. It can cause global warming. Okay. So in Kigali conference they decided हम ये तो बैन कर ही रहे हैं, हम इसको भी बैन कर देंगे. Although this is not ozone depletion, but this causes global warming. It leads to, because this is a very, very efficient greenhouse substance. So Kigali में ये clause add हुआ. While we are banning ODS, we also will ban HFCs, because while they are good substituents for this, but they cause global warming. So this was the modification in the Kigali conference. So some of this, I believe we should do as a part of environment discussions, okay, in your GS. Otherwise, we don't need it for geography as such. Okay? So maybe लिख लो margins में, and back in your room you can go and have a check. What is Montreal? What is, I think London happened first, London Convention, then we had the Copenhagen one, then we have Kigali. And do a search around and find out what are the reasons why Montreal Protocol succeeded but not Kyoto Protocol. अब तो पेरिस में भी debates हैं. The Paris conference and its objectives will survive, particularly after US has walked out of the agreement. Okay. But this is an important discussion है, एक insight वाला है. What made Montreal successful but not other climate change treaties and agreements. ठीक है? So I'm done with this part. Ozone में इतना ही काफी है. You don't need more than this. So I have explained troposphere, I've explained stratosphere. Any questions यहाँ तक, anybody? Any doubts? Any doubts till here? Okay. So let me finish off this first and come back and tell you a bit more. Okay. So mesosphere, I won't add much. Mesosphere is more of a transition zone. Okay. Mesosphere, it is, it cools with height. It cools with height. Okay. And mesosphere का जो boundary है is the coolest layer of atmosphere. It has temperature of almost -90 centigrade. The upper boundaries of mesosphere is the coolest layer of the atmosphere. Mesosphere. But एक चीज याद रहे, mesosphere also has some ions. It's a layer called as D layer. Ionosphere का एक layer है D layer. Okay. It is part of mesosphere, but this D layer, it vanishes or it disappears in the night. Ions क्यों होते हैं? Because of insulation breaking the molecules. जो insulation है वो कब ज्यादा होगा, कब होता है, डे में या नाइट में? डे टाइम. So daytime, because we have insulation, we have ions. In the night time, no insulation, no ions. वैसे कुछ याद रखो. So D layer of the ionosphere is in the mesosphere largely, but it is present in the daytime, it disappears in the night. Okay, nothing much to add in mesosphere here. The next one will be on the thermosphere. So it is from 80 to 800 kilometers, very, very rarefied layer. यहाँ पर तो atmosphere is less than 0.01%. It's very rarefied. It is largely ions, and therefore it is considered as ionosphere also. Okay, thermosphere is largely ions and ionosphere, and thermosphere is also the heterosphere. Remember 80 के beyond क्या है? Heterosphere है. The ionosphere में we have layers: nitrogen, oxygen, helium, hydrogen. This is part of the thermosphere. Thermosphere is also referred to as your heterosphere largely. ठीक है. Now, one important insight here, the thermosphere absorbs insolation. Okay. It has very high temperatures, but it has very low heat. It has very high temperatures, but it has very low heat. Heat and temperature दोनों एक चीज नहीं है. To give an idea to all of you, think of, I take a small nail, iron nail, and I take maybe a small kettle, okay, of water, small cup of water. Iron nail, I hold over the candle or some flame, okay, and the cup also I hold over, okay, some source of heat. Both I heat for 5 minutes. When I want to touch, which feels hotter? Okay, iron nail आपने 5 मिनट हीट किया और आपने कप को भी हीट किया on the same flame. Okay, because आप दोनों को हीट सेम टाइम कर रहे हो. Okay, it feels like both must have same amount of energy. ऐसा नहीं है. You're supplying same energy, but iron rod or iron nail feels more hotter, whereas the cup, it may not feel very hot, but it has more heat. So temperature is the measure of how hot or cold something is. Okay, temperature क्या होता है? Temperature is the measure of hotness. Okay, whereas heat is energy. I can have bodies with less heat but more temperature. It's something like, think of knowledge and talking. Okay, I can be a person with lot of knowledge but I speak very less. I can be a person with less knowledge but I can speak a lot. Right? So temperature आपको दिखता है. Temperature is the measure of how hot something is. Something can be very hot but very low heat. Okay, so एक formula, if some of you know, that heat जो होता है, energy है, इसका formula क्या है? Formula is mass into specific heat into temperature. MC theta in basic physics में, mass, this is the property of the body called as specific heat. How much energy something requires to increase this temperature by 1 centigrade per unit weight. Okay, and this is temperature. If something has high temperature but zero mass, heat कितना होगा? Zero हो जाएगा. Okay, so thermosphere has high temperatures but molecules ही नहीं है वहां पर, so very less mass. ठीक है? So thermosphere, yeah, delta theta, whatever. The thermosphere has high temperature but very low amount of heat. Is it okay, all of you here? So 1 degree, so when you say oceans are warming by 1 degree, the land is warming by 1 degree. Okay, which is more dangerous? The oceans becoming 1 degree, because ocean 1 degree means enormous heat absorb हो गया उसमें. Okay, land can get hot, cold very fast, right? सुबह hot, शाम तक it's cold. Deserts में होता है. Oceans अगर ज्यादा warm, even if the increase of 1 centigrade का मतलब है oceans ने बहुत heat absorb कर लिया. That's why when ocean temperature starts increasing, that's a huge concern for us. उसको निकालना बहुत मुश्किल होगा. Okay, and that's what's happening. The average temperature of the oceans is now increasing substantially, and that's why we say अब वो irreversible हो जाएगा after a couple of maybe years or whatever. Okay, so atmosphere reverse, less amount of heat, but high temperatures. ठीक है, all of you here? अच्छा, now let me talk about the ionosphere. Okay, so ionosphere is almost equivalent to, I said, the thermosphere, but not exactly same. Ionosphere is equivalent to thermosphere, okay, but ionosphere के कुछ layers हैं. We have the D layer, we have the E layer, we have F1 layer, we have F2 layer, we have G layer, and so on. और D में भी variants हैं, D1, D2, D double dash, and so on. जो D layer है, this generally exists from about 50 kilometers say till about 90 kilometers. So D layer is largely the mesosphere. D layer is largely the mesosphere. Okay, E layer is 90 से approximately 150 kilometers तक. Okay, F1 is from 150 till around 250 kilometers. F2 is till around 400 kilometer, and then the rest. आप इतना याद रखो थोड़ा बहुत. Some idea, basic idea about the heights. ठीक है? So the thermosphere is actually this one. This is the thermosphere. In fact, इसके beyond, if I go beyond 800 kilometer के beyond, we also call this as the exosphere, as in the outer boundaries of the atmosphere. Okay, but आप ये जान लो कि much of it is thermosphere. This E layer, अच्छा, now one by one. The D layer, this is only in the daytime. Night, it disappears. E layer day में भी होता है, night में भी होता है, but E layer can weaken in the night. F layer again only in the daytime. F2 जो layer है, this is day and night, ये ज्यादा change नहीं होता है. Some reasons, some reactions की वजह से F2 layer is there consistently. Okay, F2 layer day में भी होती, in fact night में F2 F1 merge होके एक layer बन जाते हैं. Right, the whole F2 extends up to F1. हाँ, ऐसे लिखो, don't add a paragraph here. In the table itself, लिख लो आप, D layer is, okay, in the mesosphere, mostly D layer only in the daytime, night time it disappears. E layer ये day में होता है, night में disappear नहीं होता है, but night में it becomes weak. F1 layer in the daytime, F1 in the night disappears again, and F2, okay, is in both day and night time. Forget about G, we don't need this for now. ई लेयर को एक और नाम है, इट्स ऑल्सो कॉल्ड एज कैनेली हेवी साइड लेयर. It's also called as Kennelly, Kenneley, Kennelly heavy side layer. This can reflect medium waves. Radio waves में medium waves होते थे, कुछ range of your frequencies called as medium waves. They can reflect medium waves. F2 layer is called as Appleton layer by the name of some scientist Appleton who discovered it. And this can reflect short waves. It can reflect short waves. So our discussion point here is ionosphere is very important for radio communications. It's important for radio communications. ठीक है? Yes, it's important for reflecting radio signals. Correct. Hi Arya, hello. All done, all of you? I don't see this as a paragraph, a small diagrammatic representation. Maybe some facts for your prelims. In the optional, I don't see this as an important topic. Okay, but then know this. So I think you understand this, right? Earth ka curvature hai. If I have to transmit something, okay, to say a tower here, the bend hai na. So I need some layer here. So I transmit here, yahan se reflect hoke yahan pahunchta hai. I think you know this, understand this. This is the transmitter and this is the receiver. The reflection hai, ye kyun hota hai? Because of ionosphere. So if I have got some range of frequencies in the medium waves, it can get reflected by the Kennelly heaviside layer. If I've got higher frequencies of short waves, it can go higher. From the Appleton layer, it can get reflected. They are important for radio communications and reflection of radio signals. Yes, the specific heat of water is more. Don't say oceans. Of the water is more. Take. Can I move on, all of you now? So what are the layers of the atmosphere? Okay, I've explained that. Now let me talk a few lines on the transition layers. Transition layers. Okay. Between the thermal layers of atmosphere. Okay, so we have this, we have a transition layer, then we have this, we have a transition layer, then we have this, transition layer, and the rest. What's happening in the tropopause? Falling temperatures. What's happening in stratopause? Rising temperatures. What's happening at the mesosphere? So stratosphere, sorry. It's again falling temperature. And what's happening at thermosphere? Again rising temperatures. ठीक है? हाँ लिखो heading the transition layers between the thermal layers of the atmosphere. So Anigya, that's why you have to be sure about in the night time what a frequency you will use for communication. You cannot use medium waves and low energy waves in the night communication. Okay? That's how you adjust according to where you are and what you want to communicate. Uh-oh, what happened? Yes. FM waves. We have amplitude modulation and we have frequency modulation. Frequency modulation is a different mechanism altogether. Okay, they don't use ionosphere, and FM waves are for high fidelity but smaller area. Okay, जो आपके radio waves जो आप otherwise सुनते थे, they were AM, amplitude modified, where amplitudes are kind of put in a carrier and then they're transmitted. Can I move on here, all of you? Okay, now listen. Imagine I throw a stone upwards. Okay? So you all know this, as I throw upwards, the highest velocity is when it leaves my hand. As it rises, gravity acts. It becomes slow, it becomes slow, it becomes slow, then falls down. It's rising, okay, becomes slow. At some point, it becomes stationary, okay, for a fraction of a moment, and then starts falling. Okay, so वैसे ही temperature falls, temperature falls, temperature falls. At some place, the temperature fall will stop, and then the temperature rise starts. Temperature was 30, becomes 25, becomes 20, becomes 15, becomes 10, becomes 5, becomes 0, minus 5. Okay. Then starts warming. Okay. Say, becomes 5, becomes 10, becomes 20, whatever. तो ये जो चेंज होगा, the change होगा मतलब कोई ऐसा मोमेंट होगा where it's falling, it's falling, it's falling, the fall of temperature stops. Fall stops का मतलब क्या होगा? The same temperature is maintained. I hit -5, then -5, -5, -5, -5, and then you have got 0, 5, 10, and so on. So in this layer, okay, ये line क्या दिखा रहा है? Line is what? The line is showing you what? Fall of temperature. So when temperature becomes constant, the line will become vertical. And then again the line starts increasing. Okay. Again it will become vertical. Vertical matlab hai same temperature is maintained. Okay. So 30, 20, 10, 0, -5, -10, -10, -10, -10, then 0, 5, 10, 15 and so on. So ये जो transition layer है, these transition layers, okay, are layers where the lapse rate or the rate of warming stops. Lapse means what? Fall of temperature. Lapse का मतलब गिरना. Okay. The lapse rate becomes what? 0. The temperature doesn't become 0. Okay. The lapse rate is 0. The lapse rate stops. Okay. The warming rate stops. Okay. ये warm, warming stops. Sorry. Warm, warming stops. Now cooling starts. Cooling stops. Then again warming starts. So the transition layers, these are, okay, isothermal layers. Iso means what? Same. Isotherm, isobar, isoheight. Okay. They are isothermal layers, means they are layers of same temperature with height. If I exaggerate the diagram, okay, ऐसा कुछ बनेगा. Okay, this is the troposphere. This is the transition zone. The stratosphere, the transition zone. Okay, temperature falls, temperature fall stops, increases, increase stops, falls, and so on. So ये जो layer है, this is the transition layer, and this transition layer is also an isothermal layer. Okay, it is called as tropopause. Now you know why I use the word pause. What pauses? What stops? What stops? The cooling stops. The fall of temperature stops. इसीलिए हम बोलते हैं pause. The temperature is now maintained. Same temperature रहेगा. Okay. Then this is the region of increasing temperature. ये भी आपका transition layer है. This is also isothermal layer, and we call this layer as stratopause. इसमें कोई temperature gradient नहीं है. Okay. This I also called as temperature inversion. And this is the actual inversion यहाँ हो रहा है. Something was falling, okay, pause, and then again increasing. So इसको भी हम in some books write as it's a zone of inversion. Actually, it's a zone of isothermal conditions. Don't be surprised if you hear that the tropopause is inversion layer. गलत नहीं है, but the better word would have been it is an isothermal layer. इसको inversion बोलते नहीं है. When I say inversion, I am referring to the trends of the troposphere. This is the warming layer. Warming stops. Now, this is again a cooling layer. Is it okay, all of you here? So, what is tropopause? What is stratopause? And similarly, we will have the mesopause. And mesopause has the lowest temperature. Mesopause में temperatures can hit -90 centigrade. The tropopause ये vary करता है, -10, -30, -40. Okay, but this is a far more cooler layer, -90 degree centigrade. ठीक है. So इसका रोल है in trapping the weather conditions inside the tropopause. We don't talk about these layers trapping. यहां पे weather है ही नहीं, तो क्या trap करेगा? Okay. This has a role. The tropopause has a role. The tropopause as inversion layer has a role. The tropopause as isothermal layer has a role in trapping the weather conditions inside the troposphere. Take all of you. Yeah, it varies. -10, -20. It goes as much as -30 also. It depends on kitne height pe hai. Okay? This varies, but not as cold as the mesopause. So we have 3 transition layers. We have the tropopause as one transition layer. We have the stratopause, and we have the mesopause. So I had one query yesterday. One boy called up from Jaipur. सब पूछा, doubt what सब पूछा. मैं बोला, सर एक problem है. Sir, I have seen your lectures on the YouTube, but आप जो लिखते हो कुछ समझ में नहीं आता. मैं उसका क्या करूं? मैं कुछ नहीं बेटा, अपना फेथ रख के आ जाना क्लास के अंदर में, आप सीख जाओगे धीरे धीरे. Okay. So I do not know how many of you can make sense of this, but I know you're all brilliant guys. Okay. You can see T here, you can see one P and something like P here. Your tropopause ही हो सकता है. ठीक है? This looks like S, I presume. Okay. Then you have one T here, एक T ये दिख रहा है और एक ये P होगा. ये स्ट्रेटोपॉज ही हो सकता है. ठीक है? So मेरे हैंडराइटिंग पे मत जाना. Okay. दिल देखो, दिल. The same thing I told my wife also. She told me, तुम्हारा शक्ल ठीक नहीं है. मैंने कहा वेट, हैंडराइटिंग देखा नहीं तुमने. शक्ल पे मत जाना. ठीक है? Yeah. So and this is supposed to be an inspiration for all of you. Okay. कि अगर हैंडराइटिंग नहीं सुधारा, टीचर बन जाओगे. Okay, you cannot become the officer you want to become. That's inspiration. ठीक है? बोलते हैं ना कि पढ़ाई नहीं किया, okay, शर्मा जी का छोटा बेटा ऐसा बन जाओगे. बड़ा बेटा तो आईटी निकाल लिया हो. Okay, it's like that inspiration here. Okay, anybody any problem here? Can I move on? Okay, so the inversion layer, we refer this as inversion layer, and this also is called inversion. But technically speaking, this is an isothermal layer, not really inversion layer. But ठीक है, उसको हम कहते हैं, तो we accept it. Yes, yes, you keep reading my handwriting, you will discover Harappan script very fast. That I am very sure. Okay, I think I answered one question of yours. What are the transition zones? All done here? Okay. So that's about your atmosphere layers. Ionosphere. अरे फिर क्या मिस कर रहे हो बेटा? This is, I said, mesosphere. Mesosphere starts from 50 kilometers. 80 kilometers तक mesosphere है. And then we have thermosphere. And the D layer is from this up to यहाँ तक. Okay, this is the D layer. इसके ऊपर में you have the E layer. Then you have F1, we have F2. That's why I'm saying when you say ionosphere, while I mean it is mostly the thermosphere, we also have D layer as part of the mesosphere. But it's not a very powerful one. It's a very weak ionosphere layer, and it disappears in the night time. That's about it. All good, all of you here? ठीक है? अच्छा, the next question you guys asked me, one of you asked me was, why is okay, the troposphere higher at the equator? Okay, if you look at the layers, they actually are like this. This 50 kilometers height, this is 80 kilometers height. Okay, this goes on 800 kilometer. Now this is at the poles, this is at the equator. At equator, okay, the height of troposphere is around 16 to 18 kilometers height तक है, और pole speeds around 6 to 8 kilometers. ठीक है? Equator पे the height of the tropopause is higher. Poles पे the height is a bit less. Okay? इसका reason क्या है? Reason is convection. Imagine you have a container, okay, and you're putting a lid on it. Okay, and not a very heavy lid. So when you boil water more, the lid can get thrown up a bit more. Okay, so because equator pe you got more heating, okay, so the air is pushing up more, the air pushes this more a bit more. Whereas yahan par it's cold conditions, air is sinking. I hope you know equatorial low pressure hota hai, polar high pressure hota hai. Okay, so this part is sinking down and this part will get pushed up. So that's because at equator there is convectional upliftment. At equator there is convectional upliftment that throws the troposphere to higher heights. That throws the troposphere to higher heights. All done, all of you? Okay. It's like a large cap, lid hai, dhakkan hai, lid. Yahan par its cold air is pulling it down, it comes down, and the warm air is pulling it upwards. So the tropopause bends like this. We don't have convection in the stratosphere, so this is more or less a horizontal line. Okay, so which is cooler? Equator is cold or poles is cold? Poles are colder. Where is the air rising more? Equator. So which is cooler? The tropopause near poles is cooler or the tropopause near equator is cooler? Which is cooler? Why? So at the tropopause, your temperature is measured in terms of kitna height gaya, remember 6.4 centigrade per kilometer. So ye height zyada hai. The temperature falls more here. Okay, so the tropopause is coolest at the equator, not at the poles. Surface jo hai, poles are cooler than the equator. So put a small star mark, write down. The tropopause is coolest above the equator. The tropopause is coolest above the equator. ठीक है, it almost more than 2 times height है इसका. So this cools more with height. It is warm, but it cools more with height. Okay, so tropopause is at a higher height, and tropopause at the equator is cooler than the tropopause at the poles. Abhiroop, I don't know what you mean by that question. Anybody else here? Can I move on now? Yes. Primary reason. Ozone is here and not here. Yes. Yeah, more towards poles in the stratosphere, not in here. I said stratospheric winds bring it here. Right? So more ozone is not here, it's here. Compared to what we have here. Okay? Yes. नहीं इधर नहीं बस उसका कुछ रोल होगा तो होगा. I do not know and none of them write about it. Just keep it as convection. Okay, so where is, okay, if all other factors remain constant, where is the lapse rate more? Poles or equator? If all other factors remain constant, where is the lapse rate more? Poles or equator? So lapse rate is rate of fall, वो same रखेंगे हम. It is 6.4 centigrade per kilometer. Okay, तो उसको आप No, it's same. Like I'm assuming the surface has the same properties. I'm assuming there is same conditions, day here also here. So वो हटा दें conditions. The lapse rate is constant. The temperature becomes less. ये दो अलग concepts हैं. Abhiroop, your question. So you don't have convection. बाकी जगह आपका convection नहीं है यहाँ पर. Okay. यहाँ पर convection है, so the air gets thrown up a bit more. Okay. Again, ये बहुत simplified diagram है. Reality में atmosphere is far more complex than this. It's a very simple diagram. I'm assuming the surface is same nature. There's no land-water contrast here. I'm assuming seasons का भी difference नहीं है. Okay, so all the assumptions में ये diagram stays. By the way, one curiosity question for all of you. When I say normal lapse rate is 6.4 centigrade per kilometer, ठीक है? ये value क्या value है? What value is this? How do we calculate? Any idea on this? Yeah, average value. Okay. Anybody else here? ये क्या value है? Yeah? रेशियो, ये कौन बोल रहा होगा? हाँ, मेरा गेस सही था. Temperature difference between sea level. Okay. This is a hypothetical number. ये होता ही नहीं है. This is the lapse rate for ideal conditions if, okay, the Earth atmosphere system was in balance in terms of incoming and outgoing energy. Okay, ये value का और कोई मतलब नहीं है. This is not the average value. This is not the maximum value, minimum. It's a hypothetical ideal value. Reality में atmosphere इस temperature पे cool करता ही नहीं है. ठीक है? Just for your, yeah, when the conditions are ideal conditions, जितना energy आया, उतना energy चला गया. Okay. अगर वो balance maintain होगा perfectly, in reality ये balance होता नहीं है. Balance achieve करने के लिए the whole thing is working. अगर balance achieve हो गया, then all processes stop. Why does the river move? River moves to reach the sea level. अगर sea level reach हो गया, then no river at all. I hope you got the point here. So the earth is trying to be in balance, and that balance creates winds, rainfall, precipitation, clouds, thunderstorms, cyclones. So this is not the actual rate of cooling. What is the actual rate of cooling? Anybody knows the term? Yes. The actual rate of cooling is called as ELR. ये है ideal rate of cooling. Environmental lapse rate. And ELR is variable. ELR is variable. It varies from place to place, from season to season. It varies daytime, night time. It varies land है कि water है कि forests है. The actual rate of cooling is ELR. और इसका कोई एक value नहीं है. इसका एक hypothetical ideal value है 6.4. So what is ELR? I'll teach again in some other context, but just to tell you the difference. Okay, what is the lapse rate? Atmosphere cools with height, वो पक्का है. rate of cooling will be different. Rate of cooling on the land is different. Rate of cooling on oceans is different. Rate of cooling in the daytime is different. Rate of cooling nighttime is different. Rate of cooling of winters different. Summers are different. So it varies from surface to surface in terms of surface nature, time, seasons, and all of that. Okay? Just a point to add to your discussions. That's right. But this is not the value we go by these values. An equator is also not same everywhere. In some places, it's ocean equator. In some places, it is land equator. Some places might have urbanization at equator. Some places, probably pollutants at equator. So again, the rate of cooling will change. Okay, can I move on here now, all of you? So I'm done with atmosphere. ये part से I don't see a question. At best, maybe a prelims question. Or they might surprise you with a 10 mark if they want to ask you on ionosphere maybe. Or questions like tropopause का क्या role है. But I see this more as a GS question. Okay? Let's move on. The next topic is, take a fresh page, heat budget of Earth atmosphere system. ये एक technical topic है, but again important for GS, important for optional also. And I can see this to be asked more than the other topics I've taught till now. The heat budget of the Earth atmosphere system. Okay. So what do I mean by budget? Anybody can tell me? What's the budget? Yeah, what's the budget? Budget is a statement, correct. It's a statement of what comes in and what goes out. It's a statement of revenue and expenditure. It's a statement of gain and loss. It's a statement of influx and outflux. तो कोई चीज में भी अगर आप पढ़ रहे हो कुछ आ रहा है कुछ जा रहा है, money comes in, money goes out, energy comes in, energy goes out. Okay, resources come in, resources go out, data comes in, data goes out. अगर आप पढ़ना चाहते हो, okay, we use the budget. The budget generally is more like a tabular form. You make a table. Okay, this is the influx, ये outflux है और ये अलग-अलग heads हैं. I'm earning income, I'm earning profits, I'm earning rentals, I'm earning some dividends, and I'm losing interest payment, I'm losing expenditure, I'm losing some other investments and so on. So budget is a statement of what comes in and what goes out. ये हम क्यों पढ़ते हैं? Because the fact is, Earth is continuously, incessantly receiving energy from the sun. ऐसा कोई moment नहीं है कि Earth receive नहीं कर रहा है. अगर night time है, the other side of the circle are the receiving sun, and Earth is receiving sunlight for as long as Earth has existed. अगर Earth सिर्फ receive कर रहा होता, Earth would have burnt off and exploded by now. There's some mechanism by which Earth is receiving and Earth is also losing heat. The Earth atmosphere is able to maintain a balance. The balance of temperature around 15 centigrade is the average of the Earth's surface. So this is about that. How does the Earth achieve that balance, or how is the Earth trying to achieve the balance? Write 2 sentences, लिख लो आप, write down. Heat budget is a way of studying. Heat budget is a way of studying how our planet Earth how our planet Earth receives energy and compensates that by loss of energy. How it receives energy and how it compensates that by loss of energy. Next point. Earth continuously receives insolation. Earth continuously receives insolation. So what is insolation? Incoming solar radiations. Earth continuously receives insolation. But there are mechanisms by which Earth also loses energy. Earth also loses energy, and Earth maintains its ambient temperature of around. Earth maintains its ambient का मतलब है livable, pleasant, ambient temperature of about 15 to 16 degrees centigrade. 15 to 16 degrees centigrade. Of course, I am discounting global warming. ये average है. The fact is, the parts of Earth which are very, very cold and parts of Earth which are very, very warm also. Okay, average temperatures of polar regions can be minus something. Winters can be even more colder. Okay, summers can be more warmer. But अगर average of करोगे, Earth's ambient temperature is 15 to 16 degrees centigrade. Continue. The heat budget is an attempt to understand how this balance process operates. Next point. The primary source of all heat energy is insolation. It accounts for almost 99.99% of all energy Earth has. The primary source of energy is insolation. Energy, otherwise, remember, Earth के अंदर से भी आ रहा है. We also have some inside Earth energy inside, but that is not what makes Earth warm or livable. और वो बहुत कम energy है compared to what energy Earth gets from the sun. To give an idea to all of you, the core of Earth is approximately 5,000 degrees centigrade, approximately. Whereas the core of sun is millions of degrees centigrade. Okay, so compare करोगे energy the Earth receives from interiors and sun, the sun is the more important source of energy. The primary source of energy क्या है? It is insolation. It accounts for 99.99% of all energy on Earth. Okay, and the rate at which the Earth atmosphere system receives energy is called as the solar constant. That's approximately 1.99 calories per cm square per minute. Okay? The rate at which the Earth atmosphere system receives solar energy is called as the solar constant. It's about 1.99 calories per cm square per minute. ये एवरेज फिगर आप याद रखेंगे. ठीक है? Now, don't write down, just listen to this. So we have Earth's surface, which is land plus water. This is the atmosphere, and this is the outer atmosphere. Maybe we assume at around 800 kilometers. So what comes in? This is insolation, and this is equal to 1.99 calories per cm square per minute. If I assume this is 100 units of energy, what happens is some amount of energy is reflected from the dust particles, some gets reflected by the clouds, some gets reflected from the land, and some gets reflected from the water. ये पूरा है reflection loss. We call reflection loss as albedo. I'm sure some of you have heard this term already. It's called as the albedo. A-L-B-E-D-O. Don't write. Let's listen to this first. Okay. So what happens to energy coming in? I'm assuming let 100 units come in. Is 100 क्या होता है? This is the first component of what happens. One is reflection. Reflection is different from different surfaces. Cloud का अलग reflection होगा, forest का अलग reflection होगा, rocks का अलग होगा. Rocks में भी what type of rock उसका अलग होगा. So all reflection together, I call this as the albedo of earth and atmosphere. That's one. Second thing which happens is some amount of energy gets absorbed in the atmosphere. Remember, we have ultraviolet and we also have some infrared absorption by the water vapor. The atmosphere में absorb हो गया. And there's a third component where energy travels through the atmosphere, it hits the surface and absorbed by the Earth's surface. Okay, these are the three things happening to energy. Okay, the insolation जो है, the insolation that we have, okay, it can either be reflected or it is absorbed by the atmosphere, or it is absorbed by the Earth's surface, land and water. Reflection को बोलते हैं albedo. And by some mechanisms, we have found what are the values of this. Write down. Write down. Next point, if the insolation is about 100 units, if the insolation is about 100 units, then number one, the reflection or albedo, number one, the reflection or albedo is about 35 units. And remember, ये reflection albedo किसका है? ये पूरे system का है. I can separately have albedo of clouds, albedo of dust particles, albedo of water vapor, albedo of the forest, albedo of the snow. अलग-अलग हो सकता है. But I've taken all of it together and we say this is the albedo of the earth and atmosphere system taken together. ये 35 है. Number one. Number two, the energy absorbed by the atmosphere. The energy absorbed by the atmosphere. Within bracket, part ultraviolet absorption by ozone, part ultraviolet absorption by ozone, and some absorption of IR and some absorption of IR infrared by water vapor or water droplets in the atmosphere. Water vapor, water droplets in the atmosphere. इसका जो वैल्यू है, this is 15 units. 35 units is albedo. 15 units is absorbed by the water vapor and the water droplets. IR is absorbed efficiently by water components. The third is absorbed by the Earth's surface. Absorbed by the Earth's surface. यहां पे लिखो, write down. This component is the visible spectrum. This component is the visible spectrum. ये मैंने बताया था कितना वैल्यू है विजिबल स्पेक्ट्रम का. The wavelength is 0.4 माइक्रोन से लेकर 0.7 माइक्रोन्स. ये विजिबल स्पेक्ट्रम है which is not intercepted by the atmospheric components. Which is not intercepted by the atmospheric components. Dust particles ho, cloud ho, ice crystals ho, the gases like nitrogen, oxygen, none of them. This component is not blocked by the atmosphere. So we say, we can put a star mark right down here. This implies radiation absorption capacity of the atmosphere is radiation absorption capacity or property of the atmosphere is selective. The radiation absorption capacity of the atmosphere is selective. समझ में आ रही है all of you? जैसे बुक्स रखे हुए हैं. I can read any book, but I don't read every book. Why? Because I'm selective. मुझे अच्छा लगता है पढ़ना about topic A and not topic B. I like to research more on topic X and not topic Y. Right? It's like I have food in front of me. I can eat anything, but I'm selective. I like this and not that. I prefer this and not that. So atmosphere is not agnostic. मतलब क्या है? Indifferent. ऐसा नहीं है. Atmosphere का property है कि it can absorb some range and can't absorb the rest. Like ozone है तो it can absorb ultraviolet. अगर water vapor है, it can absorb infrared. Otherwise, the atmosphere can't absorb radiations in the visible spectrum. ठीक है? So 4.7 microns में energy directly enters, hits the land and the water surface. And this amount जो बाकी रह गया, 35 is reflected, 15 at atmosphere, and this is remaining 50 units. This is the remaining 50. That is how energy coming in gets distributed. 35 is albedo, 15 absorbed by the atmosphere, and 50 is absorbed by the land and the water systems. This is, ये वाला component जो है, this is the influx part of the heat budget. How does energy come into the earth? अच्छा, one point here, देखो ये जो numbers है ना, these numbers can vary. And different scholars have used different numbers. Some have said 37, some say 13, some say 53 here, 52 here, but वो 50 के range में ही है. So what I'm writing here is my innovation. मुझे ये number आराम से याद रहता है. No, sir, we want exactly. जाओ, I'll tell you the page number of Savindra Singh, उससे अपने आप पढ़ लेना. मुझे mechanism समझाना है. I will not get extra mark if I write 34.7 or this is 12.32. Your book will give you more details. ये 15 मैंने बता दिया, इसका भी तोड़ के बता देगा. ये 35, It'll break up and scattering is different, reflection is different, diffusion is different. My recommendation, don't go down that rabbit hole. फंस जाओगे आप. Okay, 10 मार्क का क्वेश्चन होगा. Okay, broadly, I am home. ठीक है? So if you match the numbers with your NCERT book or your Savindra Singh, you might find some discrepancy. Your job to find out कितना gap है. Okay, and then do meditation on it. Okay, कि क्या करें अब, सर ने फंसा दिया है. Okay, accept करें नहीं करें. तो कल आके बताना आपके meditation का क्या निचोड़ हुआ. मैं यही लिखने वाला हूं. Okay, all the smart ones go research. Okay, the not so smart ones stay with me. 100 units of insulation. All done? ये हर बैच में कोई ना कोई आइटम नंबर होगा जो नेक्स्ट डे आके मुझे छेड़ेगा. ठीक है? तो आज मेरा मुजरा देख लो, कल आपका हम देखेंगे आइटम नंबर में. ए देखो रुस्तम, इज डेटा इनफ? नो, नॉट इनफ. कल बात करते हैं रुस्तम आपके साथ में. नाम भी ना एकदम फोड़ वाला है. ठीक है? ओके, बिलीव you'll have 1% पक्का. Okay, and you keep my word. Let's see. 25 year में nobody has disappointed me. Okay, so come back here. This is the insulation part of, the influx part of the insulation. Okay. Abhirup, you are not that. बेटा आप तो आप हो, आपसे क्या कहना. Okay. You are a different league. आपको मैं कहीं और पकड़ूंगा. ठीक है? So okay. Now again don't write, सुन लो पहले. ये influx part है. This is the outflux part. How is the energy lost from the earth and atmosphere system? Okay. So कितना absorb हुआ? 50 is absorbed by the land surface. अब इस 50 का दो तीन होता है. One is, this is the boundary of atmosphere. Some energy directly is lost as out radiation to outer space. Is gone directly. Okay? कुछ पैसा जो है मेरा डायरेक्टली सरकार लेके चला जाता है. They don't even ask me, मुझे पसंद है नहीं पसंद है, परमिशन लिया वाइफ से नहीं, doesn't matter. Okay. 30% income tax goes here. In the case of atmosphere, this is about 5% or 5 units. And this is in the range of 8 to 10 microns के रेंज में होता है. ये कितना है? 0.4 and 0.7 microns. This is how much? 8 to 10 microns. And these properties are fixed. ये earth atmosphere का property है. Right? So, this is directly lost to outer space. Okay. This range, atmosphere can do nothing. वैसे ही, for this range, atmosphere can do nothing. Atmosphere is transparent to this range of out radiations. All good, all of you here? अच्छा, उसके बाद में ये atmosphere है. Some energy is lost to atmosphere as conduction and convection. Okay. Some energy is lost because of what's called as latent heat of condensation. Let me explain this to you. देखो, say you have a container, you're supplying heat with water. So when you heat it, क्या होगा? Some molecule here will take energy, become energized and escape the liquid and come here. A water vapor ho gaya. Okay, it has taken energy called X. The X energy goes with the vapor. यहाँ पर X है इसके साथ में. It cools. Water vapor converts into water droplet. Okay. Energy क्या हुआ? Energy will be released. जब ये ठंडा होगा, right? It has energy with X. It is vapor, gas है. It converts. Converts means it becomes cooler. Energy will be given off. And this droplet will fall down as rains. तो ये प्रोसेस में evaporation and condensation में energy क्या हुआ? Energy has lost from the water surface into the atmosphere. ये जो conversion में हो रहा है इसको बोलते हैं latent heat of condensation. Latent because अंदर छुपा हुआ है, आपको पता नहीं चलता. So on the earth also, when we have evaporation, energy goes from the surface into the atmosphere. The water vapor converts into droplets, it falls down in rain, and the atmosphere receives the energy. That's why I think some of you may have experienced this. जब पहला shower होता है ना, you actually feel warm. Okay. And in time, okay, the water now starts making you feel cold also. The first showers में, when it's still drier, okay, it's warming of the atmosphere. यही है वो warm of the atmosphere. Some energy is lost to atmosphere by conduction, convection. We call this as sensible heat. We call this as sensible heat. We call this as latent heat. Okay? Now, remember we talked about radiation yesterday? Gamma rays, X-rays, ultraviolet, visible, infrared and all of that बात किया था हम लोगों ने? Okay. So, ये जो heat loss हो रहा है, ये high energy heat है कि low energy heat है? If you compare with sun is what? High energy heat. Okay. This is high energy or low energy? Low energy. So in the low energy, in the spectrum of wavelength, ये किधर आएगा? It'll be towards gamma rays or towards radio and microwaves. किधर होगा? What comes in is high energy. High energy का मतलब क्या है? This will be short wave radiations. ये कैसा radiation होगा ये वाला? Long wave. All of you wrong. ये सारा radiation है ही नहीं. समझ में आ रहा है all of you? ये common mistake होता है. I'm saying conduction, convection. Radiation क्यों उठा रहे हो आप? सारा कहानी to trap you. That's all. ये conduction, convection is not radiation. Don't call this as short wave or long wave. Latent heat. There are three mechanisms of heat transfer. What are they? Radiation, conduction and convection. Right? Latent heat लग सकते हैं. So this one is radiation. This I will say as long wave radiation. You are right. Don't call these two as radiations. Radiation है ही नहीं. Radiation means it does not require a medium to transfer. So this energy will not fit into the electromagnetic spectrum. उसमें लागू ही नहीं होता. वो बहुत अलग चीज है. Is it okay all of you here? Okay. So that's why we call it separate. Conduction, convection energy, because molecules are in touch with the surface. Because molecules are moving, okay, in convection. So these two are different type. These two are not radiations. Is it okay all of you here? So don't use long wave, short wave here. Okay, this is long wave, and this is low energy. Okay, उसके बाद में now, so there is radiation loss to outer space, latent heat loss to atmosphere, conduction convection loss to atmosphere, and you also will have radiation loss to atmosphere. एक यहां पर long wave. So any energy 8 माइक्रोन से कम या 10 से ज्यादा वो एटमॉस्फेयर अब्सॉर्ब कर लेगा. ठीक है. एंड वो क्या अब्सॉर्ब कर रहा है? विच टाइप ऑफ मटेरियल? कार्बन डाइऑक्साइड, मीथेन, your pollutants. Okay, what's absorbed? Remember those chlorofluorocarbons. Okay, so this radiation is absorbed atmosphere. Atmosphere will hold it, again will re-radiate back. Earth absorbs, again Earth re-radiates back, and this exchange goes on. In this exchange, there is a net loss towards atmosphere of around 15 units. It's like I save in the bank, I take out from ATM, I put a fixed deposit, I take a loan, I probably buy some certificates, I get some interest earnings, I give some EMI interest, I take some other instrument, maybe an overdraft, whatever. So between me and the bank, a constant exchange goes on. And in this exchange, either I will gain net or the bank gains net. So there is out radiation, there is counter radiation, there is re-radiation. It's going on continuously. इस exchange में atmosphere में होता है net gain. Okay, this is long wave radiation exchange of Earth's surface and the atmosphere. Is it okay, all of you here? These 4 things are happening. How energy is lost from the Earth's surface. Write down, all of you. Write down. The Earth's surface. So I'm discussing the outflux. The Earth's surface loses heat in the following ways. The Earth's surface loses heat in the following ways. Number 1, direct loss to outer space. Number 1 is direct loss to outer space. Within bracket, long wave radiation loss in the wavelength 8 to 10 microns. In the wavelength 8 to 10 microns. कितना है? Put hyphen. 5 units. 5 units. Number 2, energy lost to the atmosphere by conduction and convection. Energy lost to atmosphere by conduction and convection. Within bracket, sensible heat loss. Sensible heat loss. Kitna? This is about 10 units. 5 units, this is 10 units. Number 3, latent heat loss. Number 3 is latent heat loss to atmosphere. This is 20 units. बेटा ये नंबर आपको याद रखना पड़ेगा. Okay, there's conceptual, ठीक है, but some facts you must know. Okay, so direct radiation loss 5, latent heat loss 20, sensible heat loss is 10. And remember, these 2 loss is in the atmosphere, from surface to atmosphere. This is from surface to outer space. The 4th component is net radiation net radiation within bracket long wave. Net radiation within bracket long wave, bracket closed. Net radiation loss to atmosphere because of counter radiations and re-radiations. Because of counter radiations and re-radiations. ये कितना है? 15 units, 15. Okay, all of you? So, next. Total energy lost from the Earth's surface. कितना हुआ बताओ? Total energy lost from the Earth's surface. कितना है? 15 plus 10 plus 20 plus 5. कितना हो गया? 25, 25. It is 50. How much had the Earth's surface gained? 50. Balance हुआ आपका ये? 50 Earth's surface had gained and 50 Earth's surface has lost. Surface is balanced now. Next slide down. Total energy gained by the atmosphere. Total energy gained by the atmosphere. कितना है बताओ? 15 gained from long wave, okay, net radiation. 10 sensible heat gain. 20 latent heat gain plus आप ये 15 भूल गए, the short wave gain of insolation. तो कितना हो गया मिलाकर ये सारा? This is 60. The total gain by atmosphere is how much? 15 short wave. Remember, atmosphere has gained ultraviolet and infrared. और ये जो gain है, gain from the Earth's surface. The total energy gained by the atmosphere is 15 net radiation, 10 sensible heat, 20 latent heat, and 15 is short wave radiation of insolation. कितना हो गया? 60 units. And around here, this 60 units, atmosphere loses to outer space directly. This 60 units, the atmosphere loses to outer space directly as long wave radiation losses. As long wave radiation losses. What I'm saying is here, ये 15, ये 15, ये 10 और 20. This component of atmosphere जो gain किया, this is directly lost to outer space from the atmosphere as long wave radiations. Is it okay? Next, total loss to outer space. The total energy lost to outer space. कितना लूज किया आउटर स्पेस में? ये है 60, ये है 5, and this was 35. रिमेंबर एल्बिडो याद आ रहा है आपको? ये 35 है. ये ऐड करो 100. The total loss to outer space is 35 albedo loss, 35 albedo loss, 60 loss from atmosphere, and 5 direct loss from Earth's surface. अर्थ सरफेस कितना हो गया 100. How much had come in? 100. That's how the balance is achieved. Is it okay all of you here? There's no big time science, कुछ नहीं है ऐसा. Okay. See this as a CSAT preparation. Addition ही कर रहे हो और क्या कर रहे हो? You must know the name of the components. So I'm drawing again, and I'll recommend answer लिखो अगर ना, use more of diagram in this, and use conclusions maybe in points and bullets and paragraphs. So this is the influx. Influx is how much? 100 units. This is albedo loss, 35, 15, atmospheric absorption, 50. Absorption by Earth's surface. And please, यहीं पर ही within brackets, ये ultraviolet, infrared, this is shortwave radiation. Albedo is the total reflection. This is in the visible spectrum, 0.4 micron, 0.7 microns. Try to make your diagrams as detailed as possible, ताकि पैराग्राफ पे लिखना कम हो जाए. Okay? So make this detail. A paragraph पे लिखो, the balance is as shown above. Okay? The critical discussion you can have a paragraph maybe. Otherwise, numbers तो आप लिख दो as shown alongside. हो गया all of you here? 15 short wave by ozone, by 35 total albedo है ये of earth and atmosphere and dust particles सब मिला के albedo 35 and 50 is absorption by the surface. ये outflux 50 direct loss is 5 units. 0. It's in the range of 8 to 10 microns. Microns का symbol ऐसे होता है. Okay? Atmosphere में 15 is net radiation gain by atmosphere. Sensible heat gain is 10. Latent heat gain is 20. Yes, if you can draw, it'll be nice. You have all the components in a sketch. 15. दो बार करो, सब नंबर याद रहेगा आपको. It's no big deal. 35, 15, again 50. There 5, 15, 10, 20. So this is the energy gained by the atmosphere. $60 direct loss from atmosphere to outer space. ठीक है? Some other color maybe. 35 plus 60 plus 5. 100 units lost from Earth atmosphere system. $50 gain, 50 loss, surface is in balance. Okay. 60 gained, 60 loss, atmosphere in balance. 100 comes in, 100 goes out. Earth atmosphere total balance. बोलो क्या मिस कर रहे हो? $35, 65 is 100 units lost from the Earth atmosphere system. 60 how? Add karo. 15 plus 15 plus 10 plus 20. CSAT. अब ठीक है? How 60? You have this in your NCERT also. Okay. Now go back and see if you make sense of. I said NCERT के geography किताबें unfortunately are not convenient first reads because technical subject है. अब थोड़ी किताब में कितना पैक कर पाएंगे? Okay. So they simplify it and move on. All done, all of you? Chalo, that's for today then. Okay, continue tomorrow. Revise Kalina, please, all of you. Okay, revise this, I can continue a bit more efficiently. Okay, and keep coming to class. Okay, because अब एक दिन ही है आपके weekend के लिए. For some of you, weekend starts from Thursday onwards. ठीक है? Yeah, so others, so ठीक है, we continue. Yeah, Anfas, bye-bye.